In this video, we'll write a C language program for creating and displaying linked list. So already on whiteboard, I have shown you how to display a linked list, but also I will write down a piece of function for creating a linked list. Then I will display it. I'll give the function name as ll display, that is for displaying a linked list. And it's going to be a C language program, so I'll select the language as C language, then next. So it has created a project and the main function is this one. I'll clear off these comments. Yeah, project is ready. So as we have discussed, for a linked list, we define a structure for a node. So I will first define a structure, that is node. A node contains data member and a pointer to itself, that is a self-referential pointer. So I will take data as an integer type and the pointer is of type node. So struct node pointer, and the pointer name we have taken as next. Our node structure is ready. Then for implementing a linked list, I need a pointer called first. So I will declare a pointer itself here only. This becomes a global pointer. It can be directly accessed or even I can pass it as a parameter. Then here for making display function work, first of all, I will create a linked list. So for creating a linked list inside the main function, I will create an array with some numbers 3, 5, 7, 10, 15. I have taken 5 elements and I want to create a linked list using these elements. So here I will write a function for creating a linked list. Void function, and the function name is create. It will take array as a parameter and the number of elements in an array. Then using those elements, it will create a linked list. So I have already declared a first pointer here. Let us initialize that first pointer as null. Now in this create function, I will scan through this array and I will take one element at a time and I will create a node and form a linked list. So for forming a linked list, I need some variables. So I will take one variable I that is useful for scanning through that array, and also I will take a temporary pointer node t. This will help creating a new node. Then also take a pointer called last that will be pointing on the last node. It will help me to add a new node at the end of a linked list. Then as the linked list is empty right now, I will create the first node. So first assign, I'll create a new node using malloc function. So I will use typecasting, then malloc function. It will take size of struct node. It will create a new node and first will be pointing on that one. Then this first data, I will assign it as a of 0. That is the very first element I will give it. And first, next should be assigned as null because this is the first node. There is nothing beyond this one. And I will make last point on first node. Now first node is ready. Rest of the nodes, I will create them using for loop, iterating through the for loop and scanning through this array. So the first element, that is a of 0, I have created in first node, and first and the last 2 pointers are pointing there. Now inside for loop, for integer I assigned 1 onwards, I less than number of elements, then I plus plus. I am starting I from 1 onwards because already 0th element is created. Then every time I will create a new node by using malloc function. So same code I will write on struct node pointer, then malloc function and size of struct node. Then inside this t caps data, I will fill up the data of a of I. Then the t is next. There is no next node yet, so it should be made as null. Then the last node should point on t. Last next should be t. And last should move on new node t, and that t becomes a new node. That's all. This for loop, when it is iterating through all the elements of an array A, it will create an entire linked list. This create function, I'll be using it every time whenever I have to process upon a linked list. So whenever I want to create a linked list of some elements, I will create an array and I will pass it to this function. It will create an entire linked list. So right now, don't focus on how this creation logic is working. Just we will focus on display function. So come back to main function. Here I have created an array. Then I will call this function create. It will create a linked list. I will pass array and the number of elements are 5. So linked list is created. Now I'll give some gap here. Then here I will write a display function. So as we have discussed, I will write on a display function, that is iterative function, void display, and to this I will pass this first pointer. No doubt it can directly access it, but I will pass a pointer to this. So I will take a pointer p. Then the logic was simple, that is while p is not equal to null, go on printing the elements. So printf percentile d, because the data type is integer, p's data. Then after that, move p to next node. That's it. This is the only thing that we have to focus on. But already we should have a linked list, so I have already created a linked list. Now after this, I will call a function display by passing first as a pointer. So that first pointer becomes a pointer p here. So p will be pointing on the first node, then this p will scan through the entire linked list and display all the elements. It will display the data and move to next node. Let us run the program and see if there are any errors. I will remove the errors. There is a warning here that malloc function needs a header file. So I will declare a header file here. So I will include a header file here, include stdlib.h. Now let us run it. This 3, 5, 7, 10, 15 is displayed by this display function. Let us debug this display function. So inside the main function, I'll put a breakpoint here and I will run it. You can watch here inside the window, that is watch window or debug area. This array is having these values and linked list, it is already created and the first node is having value 3, that is displayed here. And next is this one and the next value is a 5. And you can see the addresses of the first node is last 4 figures are 4E90. The next is 4CA0 and next is 2F90. And if I say next, then it is having value 7. The next is a pointer to the next node and that node is having value 10 and its address is next is FB0 and the last one is null. So you can see this null also at the bottom. So you can see that entire linked list, the nodes, their addresses and the data present in them, entire thing can be seen in this debug window. Now if I continue debugging, this display function should display all these values. So p will be scanning through this entire linked list. So it will be taking these values, that is 4E90, next will be 4CA0, next will be 2F90. Let us check it. I will continue execution. So you just watch how p will be changing. Now p will also appear inside this window. Lights. Yes, p is now at first node. So it's going to print 3. So it is inside while loop right now. So it's going to enter inside while loop right now. Next, it prints the data. Then next line p is going to move to the next node. You can see that the next node is 4C0A. Right now p value is 4E90. Then it will change to 4CA0. Yes, p became 4CA0. It is on the next node now. And there the data is 5 and the next node's address is 2590. Sorry. And the next node address is 2F90. Just watch this one. I don't have to read it out. Then print the data and p moves to 2F90. Now it is on 2F90 and the node is containing 7. 7 is printed. Then p moves to 2FA0. Yes, p is on 2FA0. The data is 10. 10 is printed. Now p moves to 2FB0. Yes, on 2FB0. Now the data is 15 and next is null. So it prints 15 and the next is null. so it stops. Now P is null, so it will stop and come out of this function. So display function ends. That's all, end of this function. So I have shown you the debug area also, how this P is changing the values and moving to next node every time. And you can see the entire linked list inside the heap available here. So that's all with this display function.